This is a video presentation of Chapter 4, Section 2 in the 8th grade workbook, Integer Exponents. We'll start off and take a look at questions 1 through 14. Now, even though 1 through 14 have different headings, it's the same material that's being covered in 1 through 14. It's just that in the top part, 1 through 8 there, the base in all of the powers that you're dealing with is 10, and then when we go to 9 to 14, they all of a sudden mix it up and use some other bases. But it's the same approach. Now, some of these questions we can knock off really easily, like number 5. Number 5 says 10 to the 0th power. Well, we know that anything to the 0th power, doesn't matter what the base is, always equals 1. So the answer there is going to be 1. If we take a look at a question like 2 or 6 or 7 or 8 for that matter, those have positive exponents. Well, we've been dealing with those for quite a while. Number 7, for instance, 10 to the 1st means I'm going to use 10 in a multiplication question one time, or the other one answer would then be 10. In number 2, 10 in a multiplication problem 3 times, that would be 10 times 10 times 10, which is 1,000. So let's go on to some harder material now where we have the negative exponents, and I'm going to drop down to that 9 through 14 section, but you can use the same approaches as what we're going to do here with the negative exponent questions up top. Let's start with number 9, negative 6 to the negative 2nd power. Now, when you have a negative exponent, remember the exponent is the little number. It doesn't matter what the base is, the big number. The base can be anything, positive, negative, we don't worry about that at all. But when the exponent is negative, what we want to do is write our question out instead like a fraction. So I'm going to rewrite this as negative 6 to the negative 2nd over 1. Now, if we think about this and how we think about positive exponents, obviously we'd be in trouble. I can't take negative 6 and multiply it by itself negative 2 times. If it was negative 6 to the 2nd, no problem. I take negative 6 and multiply it by itself twice. I can do that. But I can't take negative 6 and multiply it by itself negative 2 times. I have to have a rule or a property or something to help me make that happen. Well, what we do there, when we have that negative exponent, is we're going to take that part, just that part that's negative, and flip it to the other side of the fraction. And when you flip it to the other side of the fraction, that's going to make the exponent turn positive. Doesn't matter if we're taking it from numerator to denominator or denominator to numerator, that's the effect it has, is it takes and makes the exponent part positive. If we leave a void there, or something totally vacant, we'll just fill it in with a 1 and we'll run from there. So the negative 6 to the negative 2nd, that's going to drop down to the bottom of the fraction because it's got a negative exponent. Again, flipping it to the other side is going to make it positive. So that means on the bottom of my fraction, I'm going to have 1 and negative 6 to the now 2nd power. Again, flipping it makes it positive. Now, in the top there, as you can see, I have a void now because there's nothing left up there. Well, when that happens, you just fill it in with a 1. So the top fills in with a 1. Okay, so we know what to do here because now negative 6 to the 2nd power, we can deal with that. That's negative 6 times negative 6. That's going to give me positive 36. So this is 1 over 1 times 36, or if you want to write it, we can write it as 1 over 36. And if you want, then we can divide that out. You can leave it 1 over 36, but if you want a decimal answer, we can divide 136. That's going to give me 0.02 and then 7 repeating from that point out. So the answer here, again, we can leave it 1 over 36. That's much easier to write. But if you want to do 1 divided by 36, we can get 0.027 with the 7 repeating. All right, let's try that again with number 10. Negative 9 to the negative 3rd power. All right, so we want to go ahead and write that like a fraction. So that's negative 9 to the negative 3rd power over 1. And then I want to take that part with the negative exponent and flip it to the other side of the fraction and make it positive. So that's going to flip down, and that negative 3 as an exponent is going to become a positive 3. So when I do that, that's going to change this into a blank, something. We don't know what something, but something. over 1 times negative 9 to the third. Now, since that did totally become void, I didn't have to flip something up to the top, we now know that that something is certainly going to be a 1 there in the top. And remember, the whole point of flipping it is that it makes the exponent part go positive. Not the negative 9, not the base. The base is going to stay negative. That's not a problem. It's the exponent part we have to worry about. So now we'll simplify this. Let's start with the signs here. Got negative 9 and we're going to cube it. So negative times a negative is going to go positive, times a negative again is going to flip this back to negative. So that's going to be 1 over 1 times a negative something. And the something there, 9 times 9 is 81, times 9 again is 729. So the bottom is 1 times negative 729. All right, or in other words, we can simply write that as 1 over negative 729. We could leave that as our final answer, but if you want, we can divide that out. 1 divided by negative 729 is 0.001371742. Not really a nice answer, no pattern there in the repetition. Really, it's just kind of a mess, so I'm going to leave it 1 over negative 729. All right, let's practice this one more time with 11. 2 to the negative fifth. So, again, I'm going to write this as a fraction, 2 to the negative fifth over 1. Now I'm going to take that part that's negative, and the negative exponent that is, and flip it to the other side of the fraction, and that's going to make the exponent become positive. So the bottom has already got 1 there, and now it's got 2 to the fifth. And since the top was left vacant, that's going to become a 1. All right, so we'll simplify that. 2 to the fifth. 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32. So this is 1 over 1 times 32, or 1/32. And again, we can divide that out if we want to. We don't need to, but we can. 1 over 32 is 0.03125. 0.03125, really the nicest answer we've had yet of the problems that we've dealt with the negative exponents. Okay, so now they've gotten some practice in with some exponents here. So now they're going to take that and make it a little bit harder by adding in the questions that involve order of operations with the negative exponents. So let's take a look at that set of questions. That's what you see here in 15 to 20. Let's start off with 15. 15 is actually really a pretty nice question, and you'll use a similar approach in solving 16 and 17. So once you see one, I think you'll get the hint here. 10 minus 3 plus 2 in parentheses, close parentheses, to the 0th power, plus 2 to the negative 1. Okay, so let's start here with this. All right, because we know if we're talking order of operations, that means we'd have to do parentheses first. Well, this is going to be 3 plus 2, which is going to give me 5. But then it says I'm going to have to do 5 to the 0th power, because I will then simplify that entire set of parentheses. Well, we know that anything to the 0th power, again, it doesn't matter what the base is always equal to 1. So even though that looks like a lot of work, that whole part there, when we're done, just becomes 1. So this is 10 minus 1 plus 2 to the negative first. And all of a sudden, a question that really looked like it had a lot going for it actually doesn't look too bad. Let's deal with 2 to the negative first now. 2 to the negative first, I'm going to come over here to the side a little bit and write out my work here. 2 to the negative first, well, we're going to write that as a fraction. And then what we're going to do is, because that's negative, we're going to flip it to the other side of the fraction, which will make it positive. And as you can see, that's going to leave a void in the top, so that's going to fill in with 1. The bottom is 1 times 2 to the first. Well, that's not too bad, because 2 to the first, that's going to be the same as 2. So this is 1 over 1 times 2, or 1 over 2, so that's a half. So we've got a half there when we simplified 2 to the negative first. So now this question, again, looked really nasty and it's cleaning up really quick. Now it's 10 minus 1 plus a half. Well, now it's just adding and subtracting left to right. 10 minus 1 is 9, and 9 plus a half is 9 1/2, or 9.5. Now, again, as you can see, 16 and 17 also involve those zero exponents, so I want to go to something that isn't necessarily all about the zero exponents. So let's go ahead and take a look at question number 20 there. 9 to the 0th power plus 64, parentheses, 3 plus 5, close parentheses, to the negative second power. So parentheses are going to go first because that's the first step in order of operations. So that's going to change into an 8. So this is 9 to the 0th power plus 64 times 8 to the negative second power. Okay, so I took care of parentheses. The next step would be exponents. Well, I have two of them, the one in the front and the one in the back. The one in the front, though, that's really the easy one because it's to the 0th power. That's going to become 1. Again, anything to the 0th power always equals 1. Now, 8 to the negative second power, that's the thing we're going to have to work on. We're going to write that as a fraction, 8 to the negative second power over 1. And what I want to do then is go ahead and take that part and flip it to the other side of the fraction and make it positive. So this is going to be 1 over 1 times 8 to the second power. The top was left vacant there when I moved that out, and that's why I filled it in with a 1, because that's, again, whenever it becomes vacant, that's what we always fill it in with. So we can simplify this now. 8 to the second power, that's an easy one. That's 64, not 16, 64. 8 times 8 is 64. So this is 1 over 1 times 64, or 1 over 64. So this is plus 64 times 1 over 64. Well, if we got the 64s on the diagonals, that means they cancel each other out. And all that's going to leave me when it's all said and done is 1. So all that's really left here is 1 plus 1, or in other words, that whole mess, when it's all said and done, just equals 2.